Let's talk about rate expression writing in chemical kinetics. So in chemical kinetics, meaning is in chemistry, there is when we talk about the rate or the speed of a chemical reaction, we call that area the chemical kinetics. So rate of chemical reactions measure in change in concentration with time. So let's write rate expressions for a chemical reactions. First, chemical reactions, let's take normal chemical reactions. So reactants goes to the products. So with time, reactant concentration is increasing, and with time, product concentration decreasing. Reactants are consumed to make products. So reactants decreasing concentrations to give product concentration, increasing product concentration. So let's write the simple equation A goes to B. For this chemical reaction, rate expression is rate for this chemical reaction is equal negative change in concentration of A with time. So here changing to word change, we are adding delta, change in concentration of A with time. So negative sign indicate that with time A concentration is decreasing. So that's why we add negative sign here. This is also we can write in terms of product B, change in concentration of B divided by delta T. This is the possible rate expression for this A goes to B reaction. So the plus sign here is B concentration is increasing with time, so it is plus, but here negative. Let's take another expression, another chemical reaction. 2A, 2 moles of A goes to B. So here rate of appearance of product B is equal half of the rate of disappearance of reactant A. So we can write the rate expression for this reaction. Rate is equal negative 1 divided by 2 change in concentration of A divided by delta T is equal change in concentration of B divided by delta T. Right? So for this reaction, we are writing the stoichiometric coefficient as a fraction here, and the negative sign indicate again decreasing concentration of A with time, but here the B in terms of product, it should be positive. Now for this any kind of reaction, let's write the general format. The reaction is A moles of A react with B moles of B, produce C moles of C plus D moles of B. For this general reaction, what is the rate expression? So rate expression is rate is equal negative 1 over A change in concentration of A. This is in terms of reactant A. Now let's write in terms of reactant B. Now we can write the same way in terms of the product C. It is positive then, change in concentration of C divided by time. And again, if you want, we can write in terms of the product D, 1 over D, change in concentration of T divided by delta T. So that is how we can write rate expression for any kind of chemical reactions. Always stoichiometric numbers, the coefficients we have to write as a fraction. And for the reactants, we need to add negative signs that indicates decreasing their concentrations with time. But for the products, it is positive that indicate that with time their concentration is increasing. Now let's go and find out what is the actual chemical reaction rate expression looks like. The chemical reaction I'm taking here is, let's take I minus in the aqueous form, react with OCl minus. Those are the reactants, and this reactant goes to the Cl minus plus OI minus aqueous. For this chemical reaction, what is the rate expression? We can write rate is the reaction is already balanced. First, you need to focus on the molar coefficients. It's already balanced, so we don't need to balance the chemical reaction. So rate is equal negative change in concentration of I minus with time is equal negative change in concentration of OCl minus divided by time. This is in terms of reactants. Those both are negative because it increasing the concentration with time. So let's write the same way, increasing concentration of Cl minus and OI minus with time. It is positive change in concentration of Cl minus with time is equal change in concentration of OI minus with time. This is complete rate expression in terms of disappearance of the reactants and appearance of the products. Now the same way, let's take another example. CH4 in the gas phase react with oxygen. Products are carbon dioxide and water, CO2 plus water. For this reaction, let's balance the chemical reaction, adding coefficients 2 oxygens and 2 H2O. Now chemical equation is balanced. Let's write the rate expression for this chemical reaction. Rate equal. We can write in terms of the disappearance of the reactants, that is negative change in concentration of CH4 methane with time, and if you want to write in terms of oxygen, it is negative 1 divided by 2 change in concentration of oxygen with time. And if you want to write in terms of carbon dioxide, it is positive because it is a product, change in concentration of CO2 with time is also equal to change in concentration of water H2O with time. This is the complete rate expression for this methane combustion reaction. Methane combustion produce CO2 plus H2O. So reactants disappear with time, products appear with time, increasing concentration. Now let's take calculations with values for another chemical reaction. So our reaction here is 4 moles of phosphine, 4 moles of PH3 phosphine decomposed into P4 plus 6 H2 in the gas phase. This is the chemical reactions we are considering. For this chemical reaction, the phosphine decomposition reaction, the rate of appearance of hydrogen or change in concentration of hydrogen with time value is given as 0.078 molar. Now we need to calculate what is the rate of appearance of P4, that is part 1, and part B is what is the rate of disappearance of phosphine PH3. So let's calculate first part A. We need to calculate rate of appearance of P4 with time delta T. So our rate expression, we can relate P4 and H2 as P4, change in concentration of P4 over time, is equal change in concentration of hydrogen with time. But this part, change in concentration of hydrogen with time value is given 0.078. We can substitute 0.078 here. So let's see. So change in concentration of P4 is equal 1 divided by 6 times. For this portion we can write 0.078. So the value is 0.078 divided by 6, 0.013. So the answer is 0.013 molar. This is change in concentration of P4 with time 0.013 molar. Part B is change in concentration of pH3, the disappearance of pH3 reactants with time. So let's calculate that. The rate expression we can relate phosphine and hydrogen. So phosphine 1 divided by 4, it is negative because with time it's disappear. Change in concentration of pH3 phosphine divided by delta T is equal 1 divided by 6 change in concentration of hydrogen with time. So here change in concentration of hydrogen with time value is 0.078. So the same way we can write 0.013, and change in concentration of pH3, this is 1 divided by 4, negative 1 divided by 4, we can move to the other side, it is negative 4 times 0.013, the answer is then 0.052 molar. That is the change in concentration of phosphine with time, 0.052 molar. So I hope you will understand how to write the rate expression for any kind of chemical reactions, and how to calculate the rate for appearance of the products or disappearance of the reactants.